Welcome to Mini Math Lessons with Karen, and today I am looking at some systems of inequalities, both linear and exponential as well. And so the first activity that I'm going to explore is just looking at kind of an understanding of what an inequality is and how the fact that it has more than one possible solution. So they are just looking at graphs and moving points around and kind of talking about the solutions. I'm using ClassPad.net. This is the landing page, ClassPad.net, and you can just start exploring. You don't need an account, but the activities I'm sharing are free, and if you like them, you would want to create an account to save them or modify them however you want. So the links to these are in the description. So here's the first one, and again, this is just an exploration. So here's this equation, linear equation. By this time, students have worked with linear equations, and then there's 4 points, and the first thing they're supposed to do is, find some solutions to this equation that work, and so hopefully they understand that if they put the points on the line, then this would be a solution. And to show it, they could simply understand that they're supposed to substitute in. So if I put in 4 for y, and -4 times -0.5 is 2, and 2 plus 2 is 4, so that's a solution. Then they're asked to change this to an inequality. So I think the first thing they're asked to do is to change it to less than, and watch what happens to the graph. And so what they see, and they're supposed to describe what happened, and what's this dotted line mean, how do they compare it to this. And so if they already had a point, say, where they already had it, let's just put one here. Like if this was a solution to the original equation of the line where it was an equal, is this still a solution? And what does that dotted line mean? And so if they plug it in and test it, it's not a solution anymore. And so they realize that, a dotted line means less than, so those on the line are not solutions anymore. So then they just test different points. Is this a solution, or is this over here a solution? And they're basically trying to figure out, what does it mean to have an inequality? Where are the solutions? And there's a lot of solutions, and you can kind of, if it says less than, my solutions seem to be lying to the left. So there are a lot of things they're supposed to be observing. So that's what's going on in this first section. And then we just continue that with a quadratic inequality. So they start with an inequality where there's shaded parts, and they're supposed to, again, test the points, like, are the points where they are right now solutions to this? And if they can get the calculator out if they want and calculate out if they can't do it in their head, and basically find where the solutions are. And so similar to here, maybe they come to the understanding that, if it's less than, my solutions lie to the left, or in a parabola or quadratic underneath. Or what if I had this be a negative? So what if I switched it? Where would my solutions lie? So there's lots of things they can try and experiment and try to get an understanding of inequalities as quadratics. So that's what they're doing there. And then we move into a cubic, which again, you can change this. Where are my solutions? So basically all of this activity is helping them understand what an inequality does. If it's got the equal sign, solutions can lie on the actual curve of the inequality graph. Solutions are in the shaded region and not in the other shaded. How do you describe the solutions of this? Because there's obviously a lot more than one. And then at the end, we have 3 different inequalities graphed, and so there's different shaded areas, and so then they are asked to identify a point that is a solution for the first one only and not the others. And so it's kind of applying their understanding that they got here. So just kind of explorations, and by the end, hoping they get a better understanding of inequalities. This last one is actually a problem where we're going to actually use perimeter and area. So this requires them to understand that the perimeter of a rectangle is 2 times the length plus 2 times the width, and that the area is length times width, and in this case we're using an X and a Y. And so they have some constraints. They're building a rectangular dog park fence. They have a total of 1,000, so they can't go in over more than 1,000 foot of perimeter for fencing. Each one can only be in 10-foot length, so the X and Y have to be at least 10 or more, so 10, 20, 30, so those are some constraints. And then they have to make sure that the square footage, so X times Y, is equivalent to between 11,000 and 20,000 square feet. That's their kind of parameters. So the first thing they're asked to do is kind of write some inequalities that model the situation. And I'm not going to do that here. I'm going to go right down into the graphing, because the idea is, what are the possible dimensions that they could build this dog fence that would basically satisfy all these conditions. So they write this down. And one thing I did want to point out is, and we use this, one of the things is x times y, which is our area. So that means technically we have an exponential equation. X times y has to be between 11,000 and 20,000, right? But so when they go to try to graph this, this is going to cause an error right here. So they basically have to solve it for y. So that's where this equation right here is coming from. So basically they're going to write their parameters with their constraints, and then they're going to graph them and try to see the possible solutions in the graph. So if you look, this is that situation. Here's the area, x times y, length times width. And it has to be between 11,000 and 20,000. But in order to actually make it graph, you get an error if you try to type it this way. You have to do it where it's solved for y. So that's what this is right here. And I wanted to kind of show you some other things that have happened, because we do have some constraints. So this right here represents the perimeter. So 2 times the length and 2 times the width can't be more than 1,000 feet of fencing. But you can't have 2 feet of fencing, so you have to have an x at least greater than or equal to 10, and then that's something they have to keep in mind, that fencing can only be done in increments of 10. And then here's our area, and we obviously are not going to have lengths and widths of 0. That doesn't make any sense. But we also have to keep in mind that this is in increments of 10 as well, so we probably want the same constraints. And as you can see, you can constrain both the domain and range just by using this, I don't know how to call it, but it's this straight bracket, straight separation tool, and it's also on your keyboard. It's usually above the slanted bracket in there, but that's how you say, okay, so I only want to look at values of x that are greater than 10 and values of y that are also greater than 10. So then when we look at our graph here, I've kind of blown it up really big so that we can see it. The region that would contain my answers is where these two graphs are overlapping, right? And I don't know why I have this extra one in here. So this is where the graphs are overlapping. So maybe I want to get a point, and you can do that here by just pulling up a plot point tool. And let's make that be a darker color so it stands out. So I'm just going to plot one single point. It doesn't really matter. Let's make it at 10 and 100. And so here's the point, right? It doesn't really matter where I plot it to begin because I'm moving it. So any point within here is going to be a solution, possible solution to the dimensions of that that fence. But again, we do have to keep in mind that you can only have the length and width in increments of 10. So here might be a nice size one, a 70 by 200 would work, right? Or so this is basically, there's lots of possible solutions, and so what they're going to then do is try to describe, you know, the range has to fall between this and this in increments of 10, those types of things. So it's just a application of inequalities that we're doing here in this activity.